Hello everyone, welcome to the class ECE341, the probability and random process course. Okay, so this is a ECE341. This lecture is for the 7th week, Wednesdays. Right. Okay, so we already studied the random variable. We studied some functions about the random variables. So now we consider some properties of those functions. Properties of those functions. So which kind of functions? Remember that? Yeah, we have CDF. We have the probability mass function, PMF. We have the density function, probability density function, PDF, of random variable x. Alright. Actually, for x, for different type of x, we have different functions. If it is a discrete type, we have CDF and PMF. If this is a continuous type, we have CDF and PDF. Right. Then the properties. First one for CDF, we have several things. First one, we know the value of the CDF should be fx of x. The value of this fx will be a number between 0 and 1. Right? Because it is a probability. This is a probability, so this value will be larger than or maybe equal to 0 and smaller than 1, no more than 1. Second thing, we consider the limit of fx of x when x go to negative infinity. This will be 0. In other words, you can think this fx of capital X of x will have 0 for small x. When x is smaller enough, the value of this will be 0. And third thing about the CDF is another side of the limit. Right? Limit x go to positive infinite. What it is? It will be 1. So the graph will look like this way. Here's a 1, here's a 0, or things look like this. Here's a 1, here's a 0, here's a 0, right? Like this or this. So when x large enough, it will be 1. When x is small enough, it will be 0. Alright. And we have the fourth one. You see, the value of the CDF is increasing, right? It's going up. It won't going down. It's always going up. So we have this property. We know f capital X of x1 were larger than or maybe equal to f x of x2 if x1 larger than or equal to x2. So when x increase to x1, from x2 increase to x1, then the CDF, the value of CDF will also increase. Okay, this is for CDF. And second, for the mass function PDF, mass function PMF. For PMF, we have the first one is similar with that. So the first one, we know the value of px of x will be a value between 0 and 1, right? Because it is a probability. And second, the summation of all of these px of x for all x, they will be 1. It will be 1. You add all the things together, it's 100%, right? Alright. And okay, This is for PMF. Now for the density function, the third one is a PDF. For PDF, we also have two things. The first one, fx of x, this value were larger than or equal to 0. Okay, here this is density. This is not a probability. This is a probability density. The density will be a positive value or might be 0, no negative value, and maybe this one is larger than 1. We do not have the smaller one, the property, right? For CDF and PMF, the both of they have the value no more than 1, this property, right? But for PDF, we do not have that. And the second property of this fx, the density function, is we do integral, there will be 1 for all the x. Now run from negative to positive infinity. Similar way, the second property of PMF, just here's summation, here's the integral. Alright, okay, so we have these properties. You read the textbook, you can find some theorems to describe them. Here I just listed like this. Alright, I don't prove it. If you are interested, you can read more details in the textbook. And I think the textbook maybe they do not have all the proof of them. If they miss something, you can find some proof in the textbook. You search online, you Google, you can find the proof. All right, but I think this is obviously something similar like in those axioms of probability, right? Okay. All right. Now let's consider some examples. We do some calculation. We consider example. We suppose we do a thing like this. Suppose you have a coin. Right? Suppose we have a coin. We have a coin. Then we flip it until a hat. Until you get a hat. Flip it until a hat. Then we record x equal to the times of the flip. You flip it how many times? Maybe the first time you get a hat, okay, x is 1. If first time is not hat, you try second time. Alright. If second time is hat, you get 2. If second time is still not a hat, you will try third time, right? So keep working like that. Then you have x. Okay, so we want to describe this x. We suppose this coin has the same probability for both head and tail, both half and half. All right, it's a fair one, a fair coin, right? Okay, then we think the sample space of x will be what? I put it in this way. X could be maybe the first time you get the hat, or maybe second time, maybe the third time, maybe the fourth. It's endless, right? Even you can imagine maybe you have a chance you need even 1,000 or 1,000,000,000 times, you still do not have a hat. You keep working until like infinite. Is it possible? It's still possible. The probability should be very, very small, right? Yeah. And what is the probability? Okay, the first time you get that hat, you have 1/2 chance, right? And the first time you do not have it, then you will try second time. Okay, so this is a tree structure. Remember, we use a tree. You have head or tail. Each is a half and half, right? You get head, it's okay. This is a you have x equal to 1. And if you get tail, you will try again. You have head, you are good. X is 2. And if you have tail, you will try more time. You have a head, okay, x is 3. And the other case is tail. Then you will keep working. right? Like this. Then the probability, like x is 2, what is the probability? It's half and half, right? Here's also half. Half and half, right? Okay, so this is 1/4. And then here will be another half and half, so it's 1/8. Okay, 1/16, and so on. So we have the probability looks like this. Then we can write the PMF. PMF, what's the PMF? This is a Px of x or equal to 1/2 to the x if x equal to 1, 2, 3, all the positive integers, or 0 if all the others for other x, right? Other values other than those positive integers. For other x, it's 0. So we have Px of x. If you want, you can also have CDF. CDF is a f capital X of x. There will be a summation of them, right? So it will be 1/2 to the 1 plus until 1/2 to the x if x equal to 1, 2, 3, and so on, all the integers, positive integers. For the others, it's similar, but you need to consider some. Okay, now this here, if x is a positive larger than or equal to 1, and here I use this notation where this one equal to the integer smaller than x, well, maybe equal, the largest integral largest integer smaller than or equal to x. I use this notation to denote it. So it is this one. If x is larger than 1, and it is 0 if x is smaller than 1. Alright, so it looks like this. This is a fx. Alright, and we can do some more calculations. Here you can verify, when this x increase, this will go to infinite, right? This go to infinite. Then this summation, do we have when x go to infinite, what is the summation? The summation will tend to be 1. Make sense? You have 1 here, so you have 1/2 plus 1/4 plus 1/8 plus 1/16 plus each time you plus half and half and half more half, and the limit is just 1. So we have fx of x will equal to 1 if x go to infinite, right? You can write it this way: x go to infinite, the limit, it is 1. This is one of the property we just stated, right? Okay. And other than these two functions, we can calculate some values. We can have the expectation value, the mean value, Ex. This one for discrete type, this value will be summation of all the x times Px of x for all x, right? Then what is this? If the probability is 0, if the mass function is 0, then this term is 0. So here we only need to consider those x, so that Px x is not 0. So we look at it here. This Px is here, right? So only when x is integers, positive integers, here's a power of 1/2, right? So here this summation will be summation of x run from 1 until infinite. Here's x times 1/2 of x. So we have this. X are integers. Alright. What is this? We need some calculation. Something, let me see. We can consider this one as okay. I denote consider. Yeah, this is some calculus method. Consider a function g of t is summation of t to the x run from 1 to infinity. Here x is not a variable, t is a variable. X are the powers, they are integers, run from 1 to infinity. Then we have g prime of t, the derivative. We take derivative. What is this? This will be summation of x times t to the x minus 1, and x run from 1 to infinity, right? Okay, so what is ex? What is ex? You see, this is ex. You compare these two. Ex is g prime of t equal to 1/2, and you need times one more t. You get it? G prime of x, you times one more t is just this one, right? But t is 1/2. T is 1/2. Yeah, times one more t, you can remove this x minus 1, right? So be x. So you have this one. Okay. And what is this? What is this? This is a t plus t squared plus t cubed until infinite terms. So it will equal to t times 1 over 1 minus t. In other words, this is t over 1 minus t, right? It is this one. Okay, now we can calculate. It is t times the derivative of this. Remember what it is? This is a fraction. We take a derivative, that will be numerator take derivative times denominator, and minus, you keep the numerator and the derivative of denominator. Then here over 1 minus t, this is denominator, just square, right? We have this one. This is g prime. This is g prime, and t is 1/2. Okay, now we can have the result. This is a t. This is t prime is just 1. So this is 1 minus t, and the minus t, and here is a t. 1 minus t, take derivative 1, you get 0, right? And t is 1, so this is negative 1. So here should be plus. Minus t times negative 1. So here's 10. This negative tend to be positive, right? Over 1 minus t squared, and the t will be 1/2. Okay, so this, now let me, okay, these two cancel, right? Let me plug in 1/2. T is 1/2. Here's a numerator is just 1. Those t cancel. And denominator is 1 minus half is another half. 1/2 squared. So this is 1 over 2 times 1/4. This is 1 over 1/2. I got 2. Okay, so we have ex is 2. Ex is 2. Alright. And we can have another value, the variable. The variance, not variable. The variance x. This will be, we know it is e of x minus ex squared, right? It is this one. To calculate these, okay, here we have a formula. I put the formula here. Formula: variance of x equal to ex. Let me see. EX square inside minus EX square outside. Yeah. So x square take mean minus the mean of x take square. So we can calculate variance of x by this way. I don't prove it. Actually, to prove this, you need two paths of the way. You need to prove it for discrete type case. Also need to prove it for continuous type case, and both type you can have this result. Alright, and we can just remember it and know how to use it. That will be fine. Okay, so this one will equal to EX square minus EX square. EX we already have, right? I have 2. This is 2, so this is a 2 square is 4. And what is this? This is a 2 square equal to 4. But what is this? This one EX square, expectation value of x square. So this is a summation of this x square times the probability px of x. Is this one. Then x is also integers, run from 1 to positive infinite, all the integers. Okay, this time, what can we do? We use similar thing. Let me write it out. This is a x run from 1 to infinite, and this is a x square, and this is a g px of x. There will be 1/2 to the x. I have square here, so I still use that g of t. I still use this g of t. I take square, I get this. I take one derivative, I get this. Now I do another derivative. Use g of t again, which is summation all these tx, x run from 1 to infinite, and we know this is a t over 1 minus t again. We use this again. We have g2 prime of t or equal to, we already have g1 prime, this one, right? So 2 prime, we take derivative on this again. Then we have, let me see, I use g2 prime, or I use t times, okay, not this one. I use t times g prime t and prime. Alright, what it is? T prime, I have g prime, I have x times t to the x minus 1, and I times t, and then take derivative again. So this t cancel with this x minus 1, right? So it's a summation. This is summation x times t to the x, right? And minus 1 cancelled by this. Take derivative. So this is summation of x squared times t to x minus 1. Okay, what is this? We compare. What do we want? We want this, right? We want this one. X squared times the numbers power to x. This is x squared times t to the power x minus 1. Okay, so now we have our results here. So we have ex squared equal to t g prime of t and the prime again times t, right? And what is the t? T were equal to 1/2. Alright, similar with the method to find the EX, right? Similar, it's EX is this one. Right. Now we have similar but more complex. Alright, now let's plug in the value. We take derivative firstly. It is t times g prime. What is g prime? Actually, we already calculated before, so I can use this one. Okay, this is a g prime, right? This is g prime. It is 1 over 1 minus t with a square. Okay, this is a g prime. This is, and then prime again and times t. T is 1/2. So this is numerator is t, denominator is 1 minus t squared. Take derivative. I have numerator derivative times the denominator minus numerator and the derivative of denominator, right? Denominator take derivative over square of the denominator. So square of square, I get 4, and the t is 1/2. I need a t here, right? I have, after the derivative, I have another t here. Okay, so this is a t prime. I get 1. So this is 1 minus t squared and minus t. Okay, what is the derivative of these? 1 minus t squared equal to 1 minus 2t plus t squared. You take derivative, I get d over dt, right? Take derivative, I get 0 minus 2 plus 2t. So it's 2t minus 2, okay. 2t minus 2, alright, over 1 minus t to the 4th, and times the t, and t is 1/2. Here, if you want, you can do some simplify on the numerator, but I don't think that's necessary. You just plug in the t, then you can have the value here. I plug in t, so this is 1 minus 1/2, I get 1/2, and the square is 1/4, and minus 1/2 times 2t. 2t is 1, so 1 minus 2 is -1. Okay, over, this is a half, right? 1 minus 2 is another half. Half to the 4th. So it is half to the 4th, 2/4. 2 to the 4. 2 to the 4th is 16. Yeah, so 1 over 16. Alright, what it is? Okay, let me times 16 on both numerator and the denominator. Then denominator cancel, right? And the numerator turn to be times 16, this is 4. And minus minus plus, and 1/2 times 16, I get 8. I got 12. Alright, so this is a variance. Oh, not variance. This is a EX squared. Then we can have variance of x, which will be E of x squared minus EX squared. So this is a 12 minus 2 squared. This is 4, so I get 8. Alright, so we have the variance is 8. Actually, for variance, we have another number. We have a standard deviation. Standard deviation, which is denoted as sigma x. Sigma of x is the random variable. Sigma of that capital X equal to the square root of variance of x. So this is the square root of a. That will be 2 over square root of 2. Okay. Alright. So we finish the calculation for this example. Now let's consider another example. This time let's consider a continuous type random variable. I have x. X is a continuous random variable, and we have density function equal to, let me see, suppose this is a, okay, it is 1 minus it's 1 minus absolute value of x times k and 0. Here's absolute value will be smaller than or equal to 1. We have these. And if x larger than 1, it is 0. It's 0. Okay. And here I want several things. First one, I want to know what is k. K is unknown so far. We want to determine it. Second one, we want CDF. And third one, we want EX. And fourth, we want the variance of X. Okay, we want these four things. Now, how to solve it? First one, you want to check K. Then, how to determine it? We can use that one. Use the integral of fx of x dx is 1. We use this. We use this to determine that K. Okay, so now we have integral. Most of the x fx gets 0, right? So we only need this part. This part for x run from -1 to +1. So it is integral from -1 to +1. Here's 1 minus absolute value of x k. This is the fx, right? dx equal to 1. And this one, we know. Okay, you have an absolute value of x. For positive x, this is x. For negative x, this is negative x. So I need this is 1, sorry. So we need to separate the interval as two parts. So we have from -1 to 0. This is 1 plus 1 minus absolute value x is negative x. So this is 1 plus x dx times k. And plus from 0 +1, this will be 1 minus just x, right? Absolute value x, just x, and k dx equal to 1. Alright, then we do integral is k and times 1. 1 by integral I have x, and x, there will be x squared over 2 from -1 to 0. And plus, this one is similar. I have k, and here's x, now it's minus x squared over 2, and the x run from 0 to 1 equal to 1. Alright, this is a k times, okay, I plug in 0, I get 0. Then it's 0. The minus, I put the -1. That will be -1 plus -1 squared over 2, right? And second term is k times, it's 1 minus 1 squared over 2, and minus 0, right? Is this one? So this is a k times, inside, what is this? This is a +1, right? It's +1, and minus 1 over 2, right? 1 over 2, this is negative, so 1 minus, yeah. And plus k, this is a 1 minus 1/2, I get 1/2. 1/2 minus 0, this is 1/2, equal to 1. So okay, this is just k, right? This is half of k plus half of k equal to 1. That one is equal to 1, right? Okay, k is just 1. Yeah, this k is 1. Okay, we got k. K is 1. Alright, then we consider the second one. Second problem, we want a CDF. Right? We want CDF. We know CDF, capital Fx of x, there will be integral from -infinity to x. This is a fx dx. This is a fx, right? Actually, this is a probability of capital X smaller than x, right? This is this one. So you need an integral from -infinity to x. Integral this, you get the probability of this one. Right? Okay, then how to calculate these? Okay, here let me give a graph of fx. It will looks like, for this side, this is a -1, this is 1, so for both sides they are 0, right? And between them, when x is 1 or negative 1, it is 1 minus 1, so it's 0. When x is 0, this is k. So it is okay. It's just this one, like triangular, like this. Now fx will be integral from negative infinity to somewhere, right? To somewhere. So we have several cases. This one, several cases. If x is here, the integral from negative to here, it's just 0. When x is this place, the integral from negative infinity to this point, we need to calculate from negative 1 to here, right? Yeah. Before negative 1 is 0, nothing. And when x is here, you need the integral from negative infinity to here, then to here, right? You need two parts because this function is different. And this place, you need the integral overall until here, right? So we calculate f capital X of x equal to here, if x is smaller than negative 1, this is 0, nothing, right? If x is smaller than negative 1, the integral you just get 0. Okay, and if x is between negative 1 to 0, then f capital X of x, there will be integral from negative 1 to x, f x dx. So this is an integral. Here's a 1 minus absolute value of x, or f2x. They confused. I use x tilde here. So this is the absolute value of x tilde. K is 1, right? So no k, x tilde. And this is now this should be negative x tilde because it's negative value, right? So this is a negative 1x. This is 1 plus x tilde times dx tilde. It will be x tilde plus half of x tilde square, run from x negative 1 to x. So we have fx of x equal to x tilde. X tilde is just x, so it's x plus x squared over 2 minus negative 1 plus negative 1 over 2, negative 1 squared over 2, right? It's this one. So what is this? So this is a x plus x squared over 2 minus, I need to plug in, this is a negative 1 plus 1/2. Okay, this is negative 1/2, so it's a positive 1/2. So it's a x plus x squared over 2 plus 1/2. People like to write these in square term in the front, right? I see this one. What is this? Oh, this is just this one, right? I put 2 in front. Is x squared plus 2x plus 1. It is 2 of x plus 1 squared. Alright, this is fx when x between negative 1 and 0. And the third case, okay. First case, second case, the third case, x is here. X is here. Then we have between 0, x between 0 and 1, we have fx of x will be, what it is? It's an integral from negative infinity to positive infinity, fx dx. Now this is x, right? So this will be negative from negative 1 to 0, f x dx, plus from 0 to x, f x dx, right? Okay, this part is just I can apply this, right? This part we can apply this, right? The integral from -1 to some x. X is no more than 0, right? So just that part. So it is 2 times. Oh, sorry. This is 1/2. I move 1/2 outside. It's 1/2. So that will be 1/2 times. Now that is 0. Right? So 0 plus 1 squared. And this part will be 0 to x. Here's 1 minus x. After value x, right? After value x, but now it's just x, right? Positive x. So this is dx. I use tiered. These two are different, right? So it is 1/2. This is 1/2 plus this part. It is x tiered minus x tiered square over 2, and x run from 0 to x. X tiered run from 0 to x. So it is 1/2 plus I put x. This is x minus x squared over 2 minus 0. Okay, I got. I put the square term in the front, and then the linear term, then the constant. Now I get this one. If the last part is x is this one, right? Last part is x is here, larger than 1. So if x is larger than 1, we have f(x) of x. There will be value. The integral from -infinity to x, f(x) of x dx. There will be from -1 to 0, f(x) integral, plus from 0 to 1, f(x) of x dx, and plus from 1 to that x, f(x) dx. Okay, this one we know it is 1/2, and this one is what? We just get is this, right? So let me plug in. This is negative 1 square over 2 plus no. This is this part. Right? This part is just this part. Right? This one is just this one. So, but x is 1. Right? This is 0 to x. 0 to x. Now I have 0 to 1. 0 to 1. So that x is 1. So it's negative 1 square over 2 plus 1. And plus what it is? This is 0. Right? This is 0. You see the function here, density function here. This part, integral from here to here, is just 0. So, okay, we have this. Now we have this out. It's 1/2 plus, this is also 1/2 plus 0, it is 1. Okay, so we have f(x). We have several cases. 0, if x smaller than -1. Then it is between negative, it's this one. It is a 1/2 times x plus 1 square if x is between -1 to 0. And from 0 to 1 is this. Is negative x squared over 2 plus x plus 1/2 if x is between 0 and 1. It is 1 if x larger than 1. Alright. Yeah. So we have this f(x). Alright. Then we have we need two values. EX. EX is what? Ex, by definition, there will be x times fx of x dx. X run from negative to positive infinity. But now we only need from negative 1 to 0. This is x times 1 minus a negative x. This is absolute value of x. And plus from 0 to 1, this will be density function is 1 minus positive x dx. Okay, we have this one. Then so this will be this is the first term is x, so that is x squared over 2, and second term is plus x squared plus x squared. X squared by integral I have x cubed over 3. Okay, this is from negative 1 to 0. And the second one, I have x, so this is x squared over 2, and minus x squared, that will be x cubed over 3. This is from 0 to 1. Okay, let me plug in 0. Okay, it's 0, right? 0. Then minus negative 1 squared over 2 and negative 1 cubed over 3. Okay, this is first part. Second part, 1, that is 1 over 2, and minus 1 over 3, and minus 0. Okay, what is this? This one is 1 over 2, right? This is a negative 1 over 2, right? That's ready. Negative 1 over 2 and minus 1 over 3 plus, right? It's a plus. Negative, negative, negative. I have 3 negative and 1 more negative, so it's a plus. And here's a plus 1/2 minus 1/3. Oh, you see? Cancel, cancel. So it is 0. It's 0. So Ex is 0. And then variance of x. We by that formula, it is Ex squared minus Ex s squared. And this is 0, right? This part is 0. Ex is 0. So this is 0. We only need to calculate this. So this is the integral of x squared times the density dx, run from negative to positive infinity. And by plugging the density function, we have from negative 1 to 0, this is x squared times 1 minus a negative x, and plus from 0 to 1, it is x squared times 1 minus a positive x dx. Okay, so this is x squared. I have x cubed over 3, and x cubed, right? This is a plus x cubed, that will be x fourths over 4, negative 1 to 0, and plus this one x squared, that will be x cubed over 3, and minus x cubed. After integral, I have x fourths over 4 from 0 to 1. Okay, plug in the value. 0 plug in, I get 0. Negative 1 plug in, I have negative 1 cubed over 3 plus negative 1 fourths over 4. And okay, this is the first. And second part, 1 plug in, I have 1 over 3 minus 1 over 4, then minus 0. Okay, so this is negative. This is, I have 3 negative and another negative, so the first one is positive. Positive 1 over 3. And this is a 4 of negative and 1 more negative, so this is minus 1 over 4. And plus 1 over 3 and minus 1 over 4. So what is this? I have I use 12, right? 12 is the denominator, and this is 1, this is 1, so there are 2/3. 2/3 2 times 4, so it should be 8, right? 2/3 is 4 of 12. Times 4, that's 3/4, so 2 times 4. And minus, this is also 2/4. 2 of 4, 2 times, now times 3. 2 and 3 is 6. So I have 2 over 12, which is 1/6. 1/6. Alright, so this is the variance. Alright, that's all for today. So see you next time. Bye bye.